Hi class. Today I want to go over converting from grams to moles and from moles to grams. So what we're going to use to enable us to change from grams to moles and vice versa is a conversion factor called molar mass. Molar mass is simply the mass of a compound or an element in units of grams per mole. And so this is what we use as the conversion factor. So we start with the grams of something and we're asked to convert to the moles of it. Or we start with the moles of something and we're asked to convert to the grams of it. What we're going to use to allow us to do any one of these is a conversion factor called molar mass, which is in units of grams per mole. So the letter A is going to represent any type of pure substance, just like in algebra, we use the letter X to represent any number. So A could be grams of oxygen, it could be grams of sodium hydroxide. Whatever you're being asked for, that's what your A is. So let's do an example. The first question says, how many moles of H2O, which we know is water, is 27 grams of H2O? So what it's asking us to do is to convert from grams of H2O to moles of H2O, right? So the first thing we need to do is find our molar mass, because remember, the molar mass is going to always allow us to convert from grams to moles, moles to grams. So in order to find the molar mass, we need to look on our periodic table. So we have how many atoms of hydrogen? We have 2 atoms of hydrogen, 2 hydrogen atoms, and 1 oxygen atom. Remember, to find the number of atoms, you look at the subscript. There's a 2 here to the right of the hydrogen, so that tells us there's 2 atoms of hydrogen. There's no subscript here to the right of the oxygen. When there's no subscript present, that tells us that there's only 1 atom. So we have 1 oxygen atom. So we look on our periodic table and we look at hydrogen, which has a symbol of H, and so the mass of hydrogen is 1.01. And we need to multiply that by 2 because there's 2 atoms there. On the periodic table, that mass gives us the mass of 1 atom. And then we look at oxygen on the periodic table. The mass of oxygen is 16.0. We have 1 atom, so it's times 1. So when we do the math, this is 2.02, this is 16.0. We add them together, and it gives us 18.02. So our molar mass is 18.02 grams of H2O over 1 mole of H2O. Remember, molar mass is simply the mass over 1 mole of that substance. So now we can do our conversion. We always start with what we're given. We're given that we have 27 grams of H2O. Now what we need to do is we need to multiply that by this conversion factor that we established here. But we need to write this conversion factor to where we'll be able to cancel out our grams and only be left with moles. So right here, this is like saying 27 grams over 1. So we have grams in our numerator. We need the conversion factor to have grams in the denominator so that we can cancel out grams, right? Remember, this conversion factor can be either written how it is, or we can also write it as 1 mole of H2O over 18.02 grams of H2O. So either way, we can switch these two around either way. So now that looks like a good way to write this, right? If we take this conversion factor here, that allows us to have grams in our denominator, and so we can cancel out grams. So we can say 1 mole of H2O over 18.02 grams of H2O, right? And so guess what we can do? Cancel out our grams of H2O. Guess what we're left with? Moles of H2O. Real easy. So now we just do the math. 27 times 1 is 27, and we divide that by 18.02, right? And so when we do the math, we're going to end up with 1.5 moles of H2O. So 27 grams of H2O is equal to 1.5 moles of H2O. Very easy. All right, so let's do some practice problems. The first one says convert 18 grams of carbon to moles of carbon. So first thing we always do is find our molar mass. We need the molar mass of carbon. So we look on our periodic table, and the mass of carbon is 12.0. So our molar mass is 12.0 grams of carbon over 1 mole of carbon. So we always start with what we're given. We're given 18.0 grams of carbon. We want to convert it to moles. So we need grams in the denominator. So we're going to write this as 12.0 grams of carbon over 1 mole of carbon. And guess what that allows us to do? Cancel out our grams. We're left with the moles. Now we have 18 times 1 divided by 12. And that's going to give us 1.5 moles of carbon. 1.5 moles of carbon. Moles is the unit that we wanted. Very easy. The next problem. 88 grams of carbon dioxide. How many moles of carbon dioxide is that? So what do we start with? We start with our molar mass. We calculate the molar mass. So we have 1 atom of carbon, 2 atoms of oxygen. So we have 2 atoms of oxygen, 1 atom of carbon. The mass of carbon on the periodic table is 12. When we look on the periodic table for oxygen, it's 16. So 16 times 2 is 32. 12 times 1 is 12. So when we add these up, we have 44 grams. So our conversion factor of molar mass is 44 grams of CO2 over 1 mole of CO2. Remember, we can also say 1 mole of CO2 over 44 grams of CO2. It's kind of like saying 5 over 5 equals 1. It doesn't matter which 5 you have in the numerator, which 5 is in the denominator. 5 over 5 always equals 1, right? All right, so we start with what we're given. We're given that we have 88.0 grams of carbon dioxide, and we're asked to convert to moles. So we need grams in our denominator so we can cancel it out. So we're going to use this conversion factor. 1 mole of CO2 over 44 grams of CO2. And that allows us to cancel out our grams of CO2. We're left with moles of CO2, which is what we're trying to find. So we have 88 times 1 over 44. And that's going to give us 2 moles of CO2. Awesome. All right, so now we're going to convert from moles of a substance to grams. So this is a little bit different. We're given the moles, we're asked to convert to grams. So we already figured out the molar mass for CO2 in the previous problem is 44 grams of CO2 over 1 mole of CO2. So we don't have to do that again. All right, so we always start with what we're given. We're given that we have 1.3 moles of CO2. Now we need to multiply this by a conversion factor that allows us to have moles in our denominator so we can cancel moles out. So we're going to write it just like we have it, right? 44 grams of CO2 over 1 mole of CO2. And so that allows us to cancel out our moles of CO2, and what are we left with? Grams of CO2. There we go. So now we have 1.3 times 44 over 1, and that is going to give us 140 grams of CO2, right? 140.0 grams of CO2. Very easy. The next problem says if we have 3.5 moles of sodium hydroxide, how many grams of sodium hydroxide is that? So what do? We first find our molar mass of NaOH. So I have 1 atom of NaOH, 1 atom of oxygen, 1 atom of hydrogen. Look on my periodic table. Sodium has a mass of 23.0. Oxygen has a mass of 16. Hydrogen has a mass of 1.01. We add all that together. We get 40.01 grams of NaOH over 1 mole of NaOH. This is my molar mass. It's the mass over 1 mole of that substance. So I start with what I'm given. I have 3.5 moles of NaOH. I need to use my conversion factor where moles is in the denominator. So I can use it just like it is, right? 40.01 grams of NaOH over 1 mole of NaOH. And what does that allow me to do? Cancel out my moles of NaOH. I'm left with grams of NaOH. That's what I wanted. So now I do the math. 3.5 times 40.01 divided by 1. And what is that going to be? 140 grams. Oh, and I got that other problem wrong. grams of NaOH. Awesome. So I'm going to go back to this problem here, and so this answer is incorrect. So I said 140 grams, but this should actually be 57.2 grams. 1.3 times 44 is 57.2 grams. And you guys can double check that on your calculators also. All right. So there we go. So now we should all be able to convert from moles to grams and grams to moles, right? So really quickly, I want to go over converting from grams to molecules. So if we have a tablet of aspirin, which is C9H8O4, and it contains 0.36 grams of aspirin, how many molecules of aspirin are present? Okay, so the first thing we need to do is we need to find how many moles of aspirin are in 0.360 grams. So we need to convert from grams to moles. So we need our molar mass. And I'm going to go ahead and tell you guys that the molar mass of aspirin is 180 grams over 1 mole. And I'm going to use AS for aspirin. Okay, so what you would do to find that is you would take 9 carbon atoms, 8 hydrogen atoms, 4 oxygen atoms. So you take the mass of, so the mass of carbon is 12.0, right? You multiply that by 9 because you have 9 carbon atoms. The mass of hydrogen is 1.01, multiplied by 8 because you have 8 hydrogen atoms. The mass of oxygen is 16. Multiply that by 4 because you have 4 oxygen atoms. You add all these 3 numbers up, that'll give you 180 grams of aspirin, and you put it over 1 mole of aspirin to get the molar mass. So we start with what we're given. We're given that we have 0.360 grams of aspirin. We want to convert to moles. So how are we going to use this conversion factor? We want grams in the denominator, right? So that we can cancel out our grams and only be left with moles. So we say 1 mole of aspirin over 180 grams. That allows us to cancel out our grams, and we're left with moles. So when we do 0.36 divided by 180, we're going to get 0.0020 moles of aspirin. Now that we have the moles, we need to be able to convert to molecules. The conversion factor that we use is Avogadro's number, which is 1 mole equals 6.02 times 10 to the 23 molecules. The way we can write that, we can say 1 mole over 6.02 times 10 to the 23 molecules. Or we can say 6.02 times 10 to the 23 molecules over 1 mole. Either way, it's the same. Remember, it's like saying 5 over 5 equals 1. So we know that we have 0.0020 moles of aspirin, right? We want to find out how many molecules that is. So we want our moles on the bottom so that we can cancel out the moles. So we're going to use our conversion factor like this. We're going to say 6.02 times 10 to the 23 molecules of aspirin over 1 mole of aspirin. That allows us to cancel out our moles of aspirin, and we're left with molecules. So when we work this out, we say 0.0020 times 6.02 times 10 to the 23rd. That gives us 1.20 times 10 to the 21 molecules of aspirin. So anytime you're asked to convert to molecules, you'll use this Avogadro's number as a conversion factor. 6.02 times 10 to the 23rd molecules over 1 mole. That's your conversion factor. Okay? All right, so now hopefully you guys have an understanding of how to convert from grams to moles, moles to grams, and also from grams to molecules, or even moles to molecules.